Dear students, let's continue our practice on mathematical analysis 1. And the previous lesson we began the new section, differential equation, and today we'll continue the topics in differential equations. So the next topic is first order homogeneous equations and the linear equations. So firstly, let's begin with homogeneous differential equations. Let's recall first order differential equation. It is dy over dx equals to f of x and y. This is first order differential equation. It's called homogeneous equation if the right side of this equation satisfies the condition f, then t of x, t of y, t times y equals to f, x, and y. So for all t. In other words, if our differential equation in the form like y derivative equals to f x over y, with such kind of equations we call homogeneous first order differential equation. So it means the right side of our equation is a homogeneous function with respect to variables x and y of the zero order. Or alternatively, we have differential form. So it is any pxy dx plus qxy dy is 0. This is in differential form, where px and p and q, where pxy and qxy are homogeneous functions, of the same order. Okay, this is definition of homogeneous differential equations. And now, how to solve such kind of equations? Here, firstly, we need to do substitution as y is any t times x, or let's do ux, u times x, and which leads our equation to a separable differential equation. So now we will consider any example here. So example number 1. Solve the differential equation 2x plus y dx minus x dy is 0. It's obviously that our p of x and the pxy and qxy, so this is p, our p, this is our q, yeah? They are homogeneous functions of the first order. And so now let's substitute that y is ux. And now let's do the substitution. U, it is a new function depending on x. Now dy is dux, yeah? Or let's take differential from this ux. However, I said u is the function depending on x. Here we'll get u dx with respect to u and plus x du. So from product, yeah, u times x. And substituting this into our differential equation, we obtain that 2x plus ux dx, yeah, minus x. Now instead of dy we have this one here, so x times u dx plus x du, it's equals to 0. And let's open our brackets. We will get 2x dx plus ux dx minus ux dx and minus x squared du, it's equals to 0. We obtain that they are cancelled, and dividing both sides of our equation by x, we'll get here. So look here, it is now x du. Let's move this x here. After this one, look here, 2x dx equals to x squared du, yeah. And now let's dividing by x, so it now we'll get 2 dx, hence 2 dx, it's equals to x du, or du is 2 dx over x. And now let's integrate the both sides of our equation, and we obtain that after integrating, here we have u, it's equals to 2 natural logarithm of x plus c. So see, it's any constant of integration. And now returning this old variable of y, however we substitute here y is ux, so let's return it, and then we'll get y is equals to however we have ux. So now our u is this one, 2 natural logarithm of x plus c. So our expression, our y, we need to find y. So it will be x times 2 natural logarithm of absolute value of x plus c. And here we divide by x, and dividing by x, we could lose the solution. X is 0. Could lose this solution. X is 0. And if we put x instead of x 0 here, we'll get 0. So this is solution of a given equation, x is 0. So we need to add this solution also. We have two solutions. The first one is this one, and then x is 0. This is also solution of our equation. These two ones we have. And now let's consider the next example. Example number 2. So solve the differential equation x y derivative, it's equals to y natural logarithm of y over x. So here root x is 0. It doesn't belong to domain of differential equation. However, we have here y over x. And now, rewrite our differential equation as y derivative y over x natural logarithm of y over x. Okay, so this is in the form f y over x, yeah, f y over x. Now, it means our equation is homogeneous differential equation. And now here we can make a substitution. Y is ux again, yeah. Hence, y derivative, again it is ux derivative, or it will be, let's write by derivatives, yeah. We can write by dy and dx, or just u derivative of x times and the plus x derivative, it is 1, and just u. Okay, and now substituting this into our equation, we'll get here what we'll get here. We have here d to this equation. Let's do the given one. So d, not d now, let's write without d. So it will be x times just u derivative x plus u equals to, now here we have ux natural logarithm of ux over x. Yeah, is it correct? Correct. So now divide by x, which is not equal to 0. It's not equal to 0. We'll get the next expression. So it will be u derivative of x plus u. We need to check it. So, however, here it's not from our domain. X is 0. That's why we can divide. In previous example, we did that such kind of example, and when after dividing x by x, we need to check x is 0, will be our root or not. Would be our root or not. Here it's not our root. Now let's divide it. So, and we'll get here u natural logarithm of u. They are cancelled. So what we'll get here, it's again providing to differential equation with separable variable. So separable differential equations, and here we have, let's now write du over dx. This is u prime times x. It is u natural logarithm of u and minus u here. So now it is u natural logarithm of u minus 1. And now I said we obtain the separable equation. It is du over here we have u natural logarithm of u minus 1, and then dx over x. Let's integrate both sides of our equation, and then we have here, however, we can write this du over u as d natural logarithm of u, yeah, and divide by natural logarithm of u minus 1 integral, and it's equals to this one is just natural logarithm of x, just natural logarithm of x plus c. Hence natural logarithm, it will be now natural logarithm of u minus 1 equals to natural logarithm of x plus constant. Yeah. Okay. So c, it's any constant, and now so here our c we can write as natural logarithm of x plus natural logarithm of any c1 other constant. So what gives it to us? It is now product, yeah. So it will be natural logarithm of c1 times x. Then natural logarithm of this, yeah, u minus 1, it's equals to plus minus c1x, plus minus c1x, or we need to find u. Natural logarithm of u, it is 1 plus minus c1x, or u is e the power of 1 plus minus c1x. Okay, so it means we have got two solutions. It is u is e the power of 1 plus c1x, and e the power of 1 minus c1x. If c1 is equals to 0, so it will be just y. E, I mean, so it is just y is xe. If c1 is 0, let's write it. We'll get, however, y is ux. It will be now e times x. And we can make sure that it's also solution of our equation. Let's substitute. So y derivative, it is e. It is e, and substitute into differential equation, and we obtain that x times e, here the given one, x times e, let me write here, x times e, it is xe, so it's not visible for you, yes, instead of y, just you need to put xe, because this is y, this is y prime, xe, and times natural logarithm of xe over x. X and x are cancelled, and here we have just xe is xe natural logarithm of e, or this is 1, however, so it means just xe is xe. So this is our solution, and now our y, all solution of our equation now is y is x the power of x times e the power of 1 plus c times x. This is where c is constant, arbitrary constant, so this is general solution of our equation. Let's begin a new example. Example number 3. Solve the differential equation. Which one? Let's do this one. xy plus y squared times y prime equals to y squared. So firstly, let's check, is it homogeneous differential equation or not? If we can write in this form, y prime is f of y over x, this is homogeneous equation. Yeah, we showed it. Now let's show this example satisfy this equation or not. We can rewrite our differential equation as y prime is dividing by y squared over x y plus y squared. Or if we divide by x squared, numerator and denominator, we will get y squared over x squared. Here we have y over x plus y squared over x squared. Or it will be y over x squared over y over x plus y over x squared. It shows that it is equation in the form y over x. So it means this is homogeneous equation. And now make substitution. Y is ux again, and then y derivative is u prime x plus x. U. And now substituting y and y prime into the given equation, we have x times ux plus u squared x squared, and y prime it is u prime x plus u and ux squared. Now let's simplify. So this is we can factorize the first bracket, so it gives to us u x squared. Yeah, now it is 1 plus u, then u prime, so this one like this, u prime x plus u and u square x square, u square x square. Divide both sides of our equation by u times x squared. Here we need to check. So as x is 0, x is not equal to 0, because if x is 0 here, it will be, it's not satisfied our equation. So x is 0, it's not our solution, but we need to check u is 0. So u is 0 or y is 0. If u is 0, it means y is also 0. Yeah. So if y is 0, it means so here if you put 0, it's satisfied. So y is 0, it is one solution. One solution of the differential equation. Okay, after dividing, what we will get here? It is, after dividing, it is 1 plus u, or u plus 1.
There's no internet connection at the moment.
U prime x plus u, it's equals to u. And now let's open the brackets. If you open the brackets, we have u prime x times u plus 1, just write with u plus 1, and here we have plus u squared plus u, it is u. They are cancelled. and we get the following one: u prime x u plus 1 is equals to minus u squared. Minus u squared. And now dividing by u squared and writing this u prime as du over dx and times x, let's divide by u squared, and it will be 1 over u plus 1 over u squared. It's equals to minus 1. So now it will be du. So let's do is 1 over u plus 1 over u squared du equals to minus dx over x. And now integrating both sides of our equation. Integrating both sides of our equation, we'll get the next expression. So it will be now natural logarithm of u, and this one is minus 1 over u, and then right side is minus natural logarithm of x, natural logarithm of x plus constant. Okay, so however u is y over x, u is y over x, so we can substitute our u now, and we'll get the next one: natural logarithm of y over x minus x over y now, and minus natural logarithm of x plus c. Let's open this natural logarithm, and we have natural logarithm of y minus natural logarithm of x, yeah, and the minus xy minus its minus natural logarithm of x plus constant. They are cancelled. And we have y let's do common denominator. So y natural logarithm of y it's equals to c times y plus x. Yes, this is our last expression, and now from we can simplify now, and we can write as x equals to y natural logarithm of y, times here, and minus cy. However, c is constant, you can write y is natural logarithm of y plus any constant times y. Any constant times y. And of course, we have next solution, second one, it is y is 0. Two solutions we have. Let's do the next example. Solve the differential equation. Example number 4. So here we have y prime. Let's do this one. Y prime is y over x minus x over y. So solve this differential equation. Here, from the right side of our equation, we obtain that x is not equal to 0 and y is not equal to 0. And we can make substitution here. Y is ux, and hence y prime is u prime x plus u, and hence after substitution, we have u prime x plus u equals to ux. This is homogeneous equation. Or we have yx, and this is equation in the form f of y of x, y over x, ux over x minus x over ux. So they are cancelled because we have x is not equal to 0. Then after cancelling, what we will get, u prime x plus u, it is u minus 1 over u. U and u also cancelled. And here we have just du over dx times x, it's equals to minus 1 over u, or hence let multiply, so it will be u du, it's minus dx over x. Let's integrate both sides of our equation, and we obtain that u square over 2, it will be minus natural logarithm of x plus constant, or let multiply by 2 both sides of our equation, and we'll get u square, it is minus 2 natural logarithm of x plus 2c, or any other constant, just c. Yes, so it will be now u squared is c minus 2 natural logarithm of x, c minus 2 natural logarithm of x, or we have u is plus minus square root of c minus 2 natural logarithm of x. And then we do the substitution again. U is y over x. After this substitution, we'll get here y is y is ux just. So after substitution, we'll get plus minus x, just multiplying by x, c minus 2 natural logarithm of x. This is general solution of our differential equation. Let's continue and consider the next example, example number 5. Example number 5. So find the general solution of differential equation x cubed plus xy squared y prime y cubed. So this is, here it's easy to see that this is homogeneous differential equation, and we can substitute y is with ux. Okay, and y prime is, again, it will be u prime x plus u. Now, after substitution, we have here x cubed plus x times ux, u square x squared. Y prime, it is u prime x plus u, and the y squared is y cubed, u cubed x cubed. Okay, good. Now let's factorize the left side of our equation, and we can factorize x, factor out x cubed. And here we have 1 plus u squared and u prime x plus u and u cubed x cubed, u cubed x cubed, and divide both sides by x cubed. Here you need to notice that x is 0 is not solution. You can check putting x is 0 here, and it's not our solution. So, and now what we'll get after dividing, we have just 1 plus u squared here, and u prime x plus u, it's equals to u cubed. Okay, so if you open brackets, we have u prime x plus u plus u square u prime x plus u cubed is u cube. They are cancelled to u cube. And here we have, just let's write without this factors. So just write like factor out like these two ones. U prime x, it is 1 plus u squared and equals to minus u. So this one now is du over dx times x, 1 plus u squared is minus u. Now it will be now du over, just du will be, yeah. So it will be 1 plus, let me write firstly, 1 plus u squared over u du and minus dx over x. And let's integrate both sides of our equation. Hence we have the following integrals. So integral 1 over u plus u du equals to minus natural logarithm of x plus constant. So it will be now natural logarithm of u plus u squared over 2. Natural logarithm of u plus u squared over 2 equals to minus natural logarithm of x plus constant. So our u is y over x, and we can substitute one more time this u. Hence natural logarithm of y over x plus y squared over 2x squared minus natural logarithm of x plus c. And after opening this natural logarithm, it will be natural logarithm of y minus natural logarithm of x, as previous example, yeah, and plus y squared over 2x squared equals to minus natural logarithm of x plus constant. So here they are cancelled, and we have the next one, natural logarithm of y, it's equals to, so what we'll get here, c constant minus y squared over 2x squared, y squared over 2x squared. Hence y is, just write with e the power, e the power of c minus y squared over 2x squared, or this e the power of c times e the power of minus y squared over 2x squared. However, e the power of c is also constant, so we can substitute e the power of c with any other constant, c1 for example, and times e to the power of minus y squared over 2x squared. Of course, c1 is now greater than 0 because this is e to the power of c. And this is general solution of our equation. This is general solution. Let's consider the next example. Example number 6. So, find the general solution of differential equation. Y prime is which one? Let's do this one. X minus y plus 3 over x minus y. Okay, so in this case, look here, in fraction, if we consider as two lines, yeah, we have parallel two lines, x minus y plus 3 and x minus y, in numerator and denominator respectively. So now we can do changing variable as z is x minus y, or y is now x minus z. Hence y prime is x prime is 1 and z prime is z, derivative of z is just z prime. So z is function depending on x and y. Here, after this substitution, as a result of the substitution, we'll get the following differential equation: 1 minus z prime. 1 minus z prime is now z plus 3 over z. In such kind of examples, you can do this substitution. So, hence, this is we can write as 1 plus 3 over z. Now, you can see 1 and 1 are cancelled, and we have z prime is minus 3 over z. And now, this is a separable equation. So dz over dx is minus 3 over z, or z dz is minus 3 dx. Let's integrate both sides of our equation, and hence we'll get here z squared over 2 equals to minus 3x plus c constant. Or now, however z is x minus y, let's do inverse substitution, and we have here x minus y squared. X minus y squared, it's equals to minus 6x plus 2c, or just we can replace it with other constant. So it will be c 1 minus 6x. Or now we can write x minus y as plus minus square root of c1 minus 6x, or hence y is now y is x plus minus minus plus, it doesn't matter, plus minus c1 or c minus 6x. This is general solution of our differential equation, given differential equation. And now let's move to the next section in our lesson, linear equations of first order. Firstly, let's give a definition of linear equation of first order. So, differential equation of type y prime plus any ax y equals to f of x, where a of x and f of x are continuous functions, is called a linear non-homogeneous differential equation of first order. If the right side of our equation, so f of x is 0, it will be homogeneous. Now, we will consider two methods of solving linear differential equation of first order. First one is using an integrating factor, and the second one is method of variation of a constant. And let's consider the first method using an integrating factor. Factor. Okay, so if the linear differential equation is written in the standard form like this is standard form. In standard form, let me write in one more time. So the integrating factor is defined by the next formula, and let denote by u of x, and it will be e the power of integral ax dx. This is integrating factor. This is integrating factor. If we multiply the left side of the equation by the integrating factor, u of x, it converts the left side into a derivative of the product y times u of x. Y times u of x. And general solution of differential equation will be y is integral u of x f of x dx plus any constant over u of x. This is general solution of differential equation using integrating factor. This is first method. And the next method is, which is called method of variation. Method of variation of a constant. This is second method. So here, firstly, we need to find the general solution for homogeneous equation. Y prime plus ax y is 0. And then this general solution of our equation this general solution, so it's obviously it contains a constant of integration c, and we replace this constant with a certain function, c of x. A certain function c of x after finding this solution of homogeneous equation, and by substitution this solution into non-homogeneous with f of x, differential equation, we can determine the function c of x. And of course, two of these methods leads to the same solution. Okay, let's consider now examples, and I think it will be clear for you after examples. Okay, so example number 1. Solve the equation. Let's do this equation. Y prime minus y minus x e to the power of x is 0. So we need to solve this equation, and let's rewrite our equation in standard form. What was our standard form? Y prime plus axy, one more time, let's recall it, is f of x. So in our case it will be y prime minus y is x e to the power of x. Our f of x is x e to the power of x. And now we solve this equation. Now let using the integration factor. Integrating factor, it will be u of x. It is e the power of integral. Our a is -1, so minus 1 dx, minus dx it is, or just e the power of minus x. So this is our integrating factor. And now then the general solution of this linear equation is and after multiplying this e to the power of x to both sides of our equation as a factor, and the general solution of our equation will be, let's recall one more time, it is u of x, f of x, dx plus constant over u of x. So now this is formula for you, and now our y is now here integral of e to the power of minus x, and times, this is after multiplying, we will get this one, times f of x is x power x times e to the power of x, they are cancelled, look here, and dx plus constant over u of x, so it is e to the power of minus x. Now it's equals to integral x dx plus c over e to the power of minus x, or e to the power of x squared over 2 plus c. So this is general solution of our equation. And now let's consider the next example, example number 2. So solve the differential equation xy prime y plus 2x cubed. So this is again linear differential equation of the first order. Now let's do it with the second method, method of variation of a constant. Okay, so here firstly we need to solve the homogeneous part of our equation, which is equal to 0, this one, so xy prime is y. This is equation with separable variables, and we'll get here dy over dx times x is y, or dy over y is dx over x. Hence, after integrating both sides of our equation, we'll get natural logarithm of y is natural logarithm of x plus any constant, which we can write as natural logarithm of c. And here we have the following answer: y is c times x. This is general solution of homogeneous equation. General solution of homogeneous equation. And now we replace our constant with any unknown function c of x. So c is now c of x, depending on x. Okay, now our equation is y is c of x times x. Then y prime is it will be c prime of x times x plus c of x. So we changed our constant as function now, and substituting this into our equation, the given equation now, we'll get here x times c prime x plus c of x, yes, and it's equals to c of x times x plus 2x cubed. Okay, so do we have common terms? Yes, we have. X times c prime x plus x times c of x equals to c of x times x plus 2x cubed. They are cancelled, and hence we'll get c of x. So here not plus here, just multiplication. So it will be x squared. Sorry, x squared, and hence we have now we can divide by x squared, yeah, both sides, and we'll get c prime of x is 2x. C prime of x is 2x, and now we can find this c of x, integrate this expression, both sides of our equation, and we have integral of 2x dx. So it will be x squared plus c1. Now any other constant, arbitrary constant. So now our general equation is y times c1 cx of x. Yeah, now just replacing our cx, and we have here y prime is x squared plus c1 times x, or x cubed plus c1x. This is general solution of our given equation. So I showed two examples with different ways. With these two ways, you can do by this way which is for you comfortable. And now let's do one more example. Exercise number 3. So solve the initial value problem. Y prime minus y tangent x is sine x, where y0 is 1. Let's do this example, initial value problem. First, we calculate the integrating factor. Let's do with integrating factor this example. So u of x is integral of e the power of integral. Here a is minus tangent x dx. So it is let's here compute the tangent x dx. This is we did such kind of examples using this sine x or cosine x dx. We can write in differential d cosine x with minus, here we have minus, and over cosine x, so it means this is minus natural logarithm of cosine x, yeah, and plus constant. Now we don't need this constant here, so it will be now e the power of we'll add this constant in our general solution, e the power of minus two minuses we have, so just natural logarithm of cosine x. This is integrating factor, so this is equals to cosine x, of course, in absolute value. This is equals to cosine x. Now we can take our integrating factor function ux, just cosine x, just cosine x. Yes, positive value. And now firstly we need to make sure that the left side of equation is the derivative of product y x times u of x. If it is correct, so we can continue. Let's do it. So y prime minus y tangent x times cosine x, yeah, and now if we open it, it will be y prime cosine x minus y sine x, yeah, they are cancelled because tangent is sine x over cosine x. And now this is derivative of y times cosine x. Yes, so this is correct. So it is yx times u x prime. And now the general solution of our equation is 1 over u of x times integral, yeah, u of, however, this is now like this. We have this, we multiply two sides like this. Let me write here y prime, I mean y x u of x prime, it's equals to our f of x times u of x. Yes, f of x times u of x. Now to find this y of x u of x, how we get this general solution with y, I will show here. So it will be f integral of f of x u of x, yeah, and plus c, of course, and dividing by u, it will be 1 over u of x times this integral f of x u of x plus c. How we get this general solution? Yeah, this is general solution. This is general solution. By this way we will get our general solution. Okay, here we have now u of x times f of x. F of x is sine x, and dx, of course. Here, of course, dx. We need to add dx. So plus constant. And now it will be 1 over cosine x integral cosine x sine x dx plus c. So if we continue, this is sine 2x over 2. So it will be 1 over 2 cosine x integral sine 2x. Sine 2x, and then dx plus, here we need to write in brackets. Our cosine we need to divide by, but it doesn't matter when we're dividing by cosine x. Okay, so let's do like this. So now it is cosine 2x over 2, or with minus, of course. So it will be c over cosine x minus cosine 2x over 4 cosine x. So we have initial value, initial condition, y0 is 1. Let's put it and find this constant. So y0 is, this is our y, yeah. So c over cosine 0 minus cosine 0 over 4 cosine 0. So cosine 0 is 1, and we have c minus 1 over 4. It is 1. Hence, c is 5 over 4. So we found our c, and now our general the solution of initial value problem is y is 5 over 4 cosine x minus cosine 2x over 4 cosine x, or just 5 minus cosine 2x over 4 cosine x. This is solution of our initial value problem. So I think it's now clear how to solve linear equation, I hope. It was last example. If you have any questions, any problems, you can on our discussion group, and the next time we'll continue this section, differential equations. Thank you for your attention.